All right, so now we have a block that's sliding down an inclined plane, but the plane now has friction. So we have the heights changing, the speeds changing, and there's the work done by friction. All these three elements are part of the energy equation, so we're going to use the energy equation to solve this. Okay, I have a 3 kilogram object here. I am going to release it from rest. It is placed on an inclined plane, and you can assume that it's placed with initial velocity of 0, and it's going to slide down. Okay, 8 meters above the ground. 8 meters above the ground means this distance here. The height is 8 meters, and the angle is 53. In previous problems, I gave you the length, and you had to find the height. Now I'm giving you the height. The coefficient of friction right there between the block and the plane is 0.5. So, as always, let's start with the energy equation. Ki, Ui, work non-conservative, kinetic final, potential final. No kinetic energy at the beginning because there's no speed. The potential energy exists because you have a height. The work done by non-conservative forces is the work done by you plus the work done by friction. In this case, you're just watching this block go down, but there is work done by friction. I also have a, let me expand this out here. This is mgh initial. And then on this side here, there is kinetic energy because we get to the bottom with some final velocity. But there is no potential energy because when you're at the bottom, your height is 0. All right, and we're looking for V final, so we have to know all these other numbers here. Just to plug in something real quick, mghi, the work done by friction is negative Fd and half mv final squared. All right, let's start plugging numbers. I got a 3, a 10. The initial height is an 8 that was given to us. What about friction? We have to calculate friction. So I want to remind you that friction is always mu normal, but in an inclined plane, we have on an inclined plane, if you remember, normal is perpendicular to the surface. So normal does not equal mg. Normal equals mgy. Okay, so normal equals mgy, and mgy, I hope you remember, as long as the angle is down here, which is the correct place for the angle, the more usual place for the angle, mgy will be mg cosine of theta. Remember, x goes with cosine, but on the inclined plane, it's backwards. Okay, so this means that friction will be mu normal, and normal is all this, so mu mg cosine of theta. And if we plug this in, mu is 0.5, mass is 3, gravity we're going to round it to 10, and the cosine of 53. If you do all this, I have it here, you get a 9. Okay, 9 newtons. So we can plug this in here. It's a negative 9 because of this negative here. The distance is, now what is the distance here? Well, usually in previous problems I give you the distance and not the height. Now I'm giving the height, which was good here because we needed the height, but it's bad here because we now need the distance. So in a lot of problems, if I give you the height, you still have to find the distance, or if I give you the distance, you still have to find the height. We can use that little equation, and d sine h equals d sine of theta. But in this case, I don't want h, I want d. So d equals h divided by sine of theta. Let's start with numbers there already. 8 divided by sine of 53. And that's actually 10 meters. So a 10 goes right here. Half 3 v final squared. Notice how we have all the numbers. Now it's just a matter of doing the algebra here. So this is 240 minus 90 equals 1.5 v final squared. And if you calculate this, you get that v final is 10 meters per second. All right. That's it. That's it for this one. Let's go into the next one.